Hello and welcome to another college algebra assistance video. Today we'll be dealing with polynomial functions and we'll be looking at end behavior. The examples we'll be doing today will be using limit notation to describe the end behavior of the following polynomials. We'll also see if we can complete this activity without using a calculator. Now our first equation that we'll be looking at is f of x equals x to the 7th minus 3x to the 6th plus 45x to the 4th minus 321x plus 729. Now looking at this equation, this is a 7th degree polynomial. And it's an odd function. We can also look at the sign before our dominant or our lead coefficient, which is positive. So we have a positive function. Now if we look at that to make our limit notation, since it's an odd function, the limit as x approaches negative infinity and the limit as x approaches infinity are going to be two different things. Now that we know that, we know we'll need two different limit notations for it. So we'll need the limit as x approaches infinity of f of x, and we're also going to need the limit as x approaches negative infinity of f of x. Now what we can look at is if we kind of just look at the x to the 7th part. When x gets big enough, it's going to dominate whatever the x to the 6th, the x to the 4th, the x, and the constant 729 do. So if we look at what happens when it gets really big, if we were to put in a really big positive x number, we're going to get out a really big positive number. So that means that as the limit as x approaches infinity for f of x is actually going to be infinity, because as x gets really big, this is going to get to a really big number, like infinity. Won't actually get to it, but it'll approach infinity. Now we look when we put in a very large x, but it's negative, what would happen is, again, the x to the 7th will dominate all of this, and since it's an odd function, if we put in a negative number, we'll have an odd number of negative numbers being multiplied by each other, which will give us a negative output. Therefore, the limit as x approaches negative infinity will be negative infinity for f of x.